So for section 10.6 here, we're going to introduce a notation that is simply going to allow us to condense and write series in an easier fashion, a condensed fashion. And it's called sigma notation. It's called sigma notation because we're going to use a sigma sign. And we've got four places that we're going to be looking at stuff all around: top, bottom, outside, and to the right. So for an example, considering this first series up here, 2 plus 4 plus 6 plus 8, I note that there are 4 terms. And I know that I can write a formula for the nth term. What would my formula be for the nth term? The nth term, if the pattern continues, looks to simply be 2n. And I could use, instead of the counter n, I could use the counter k. I could use whatever I want. So for sigma notation, our inputs are going to be just like they were for sequences, since we're dealing with series. Our inputs are positive integers, although you could change your counter and include negative integers if you want. You could begin with a -3 as your first starting point. But generally you're going to begin with 0 or 1. So if I want to write sigma notation, what I do for this first one is write my rule for the nth term, which is 2n, and then I need to start. And what do I start with? I start with n equals 1. So starting is going to be at the bottom. I'm going to say start with n equals 1. And how many terms, what am I going to go up to? What am I going to go up to? What's my last n that I'm going to plug in? And the answer is 4. So I'm going to write up top here, I'm going to say I'm going to start with n equals 1. I'm going to go up to n equals 4. And that is going to be my representation, my condensed form for talking about this first series. How about the second one? Well, the second one, again, same strategy. I know I'm going to start with, I want to sum up something. If I start with my counter, I'm going to choose k this time instead of n. If I start with 1, there are 5 terms, so I'm going up to 5. The first thing I notice is I've got alternating positives and negatives. And we talked a little bit about that in class already. The way that I can generate for my nth term here is I know that if I have -1 raised to some power, then if I plug in 1, some power, I get a negative. If I plug in 2, I get a positive. If I plug in any odd-numbered input for my exponent, I'm going to get a negative number. If I plug in an even number, I'm going to get a positive number. So odd, negative, even, positive. So the first term over here is positive. So if I want the first term to be positive, say I had a k plus 1 up here. Is that going to give me alternating positives and negatives every time that I need? And let's just try it out. The third term here, 3 plus 1 is 4. -1 to the 4 indeed is positive. So that's good. So I know that for my nth term, part of it will be multiplying by this. What's the rest of my thing? Well, I've got 1/2 raised to the, looks like it's to, let's see, for k equals 1, raised to the first, for k equals 2, raised to the second, raised to the third. So it looks like indeed I've got raised to the kth power. So that's my nth term for that series. So again, I'm simply going to put my nth term down here, -1 to the k plus 1, times, now I could write that 1/2 to the k as 1 over 2 to the k, or 1/2 to the k. And so you're looking to put the nth term as your rule in next to the sigma notation, and you've got to have a starting point and an ending point, and you can pick whatever you want your counter variable to be. Generally it's either an n or a k, or the two popular choices, but you can choose whatever you want. And that's a condensed way to write out that series up there. In this case, there we go. Now suppose we want an infinite series. Suppose we want to add up infinitely many things. Well, what I'm going to do is say the limit, and let's say our counter variable is an n. Let n go to infinity of wherever you want to start. Say we start here at n equals 1, and I have some rule out here, and I'm going to give you the rule. Let's say it's 2n minus 1. That's my rule. So if I want to generate this series now from sigma notation, I've given you here how to write my notation for writing a infinite series. And your text, our text and other text will often simply just say, put an infinity up here, start at 1, 2n minus 1. Those are equivalent notations. What is this if I want to expand this now? Here's my condensed form. If I want to expand it, I just start in with n equals 1, and then n equals 2, and n equals 3, and I generate the series from my rule for the nth term. So plugging in n equals 1, I get 2 minus 1 is 1, plus plugging in n equals 2, I get 4 minus 1 is 3. Plugging in n equals 3, I get 6 minus 1 is 5, plus dot, dot, dot. And there's my expanded form for this infinite series expressed with sigma notation. Sorry about the phone.